Hi, and welcome to the lecture on breakdowns, failures, and inventory. So first we're going to start talking about breakdowns and failures. And this comes up in reliability contexts, but it's also going to come up in the context of the barbecue pit as well, which is something I didn't quite appreciate during my last lecture. But anyway, let's get on and talk about it. So let's look at this self-service station breakdown. So remember, you should have NIMITs open if you do not, or at least be aware that this is going to be a good thing to have. Because it will help you be able to follow along and understand the lecture. And in fact, you should pick up from where we left off last time. So remember, last in the data tables, we had small, medium, and large entities. And there was a little bit there on a breakdown. So what we're going to model is that there's a self-service urn, and it can serve 100 cups of coffee. It has two urns that it switches out at the self-service station. So basically, one of those two urns is there. And after 100 students get coffee from the urn, a barista needs to switch out the urns. It typically takes 2 minutes, but can be done as quickly as 1 minute or take as long as 5. So first of all, when you see this, you should note the modeling assumption. All cups are the same, okay? That's obviously not true, but for now, let's just think of it that way. Okay, so while the barista is switching the urn, there's what we call a failure. There's a breakdown. The students cannot fill their coffee cups at the self-service station and have to wait until the barista is done. So how do we do this? So we go to our self-service node remember we're in the facility tab of Simio, and we look at the reliability logic. And what we're going to do is we're going to change that from no failures. So you have to scroll down in that process window on the far right, from no failures, and we're going to change that so that there's a failure type, okay? So the way in which we do that is we need to think about all these different failure types. Well, which one should we use here? There's calendar time-based, event count-based, processing count-based, or processing time-based. Okay, and so let's think about what those all mean. So calendar time-based might be like a power outage. So every now and then there's a power outage. That's based off the time of day. Processing time-based, that would be like if there was a failure in the system, like the photocopier had a paper jam. You might have an event count based. So this would be based off of the number of occurrences. Every 20 things, something happens. So that could be maybe vehicle breakdowns. It could just be based off of we know that every fifth person is going to cause a problem in the system. Maybe because we know that after 5 people come, we're done, we've run out of some resource. So we might just use this failure to model that. Processing count based, that could be the photocopier running out of paper. Okay, so that's types of failure. So for ours, we are going to use the processing count base because we're going to say after 100 cups have been, after 100 cups, so that's processing count based, the count between failures is 100. And then we have this time to refill. That's the time to repair. And it's that triangular distribution that we talked about. Okay. When we run this, we see that this happens approximately twice throughout the course of the simulation. That makes sense because if we looked at the other numbers, there were between 200 and 300 cups of coffee being filled at the self-service station. Okay, so that's not the most general way to model it. We know that we actually have an inventory of coffee, and that urn, and there are different sizes of coffee. And so how do we model that? And of course, this is going to get exactly at some of the problems we have in our barbecue pit problem with the replenishing meat and the side items and all the other materials and the ribs and so on and so forth. Okay, so for this, what we need to go to is we start off in the model. So you make sure this model tab is being selected, which it should have already been. And then we select the definitions tab, okay? When you click there, we're going to click on, we're going to click first on the materials. The inventory is only to be used when we have different inventory locations. We only have one for this particular model, so we're just going to click on the material. So we click on the material. That's the thing that's going to end. So we click there. You can see that it's, when you hover over there, it's going to tell you what that says. It says that this is something that can be consumed or produced in the system. So that's really the important piece here. We can consume a material or we can produce a material, okay? So for us, of course, what we want is we want the self-serve coffee. So that's what when you create this, it's gonna have a default name. We selected it, we relabeled it self-serve coffee, okay? And we said the initial quantity is 800 ounces. That's from the description of the problem. So there's 800 ounces of coffee. Now we go to the self-service counter. Now we're going to say, okay, we need to change out the material. We need to put that into the reliability logic. So instead of using this uptime and downtime, we're going to think about the material being produced and consumed. So this is what's going to change these two fields here. Okay, so the first thing that we're going to change is we're actually going to change this so there's a task sequence in the process type. And there's going to be processing tasks, and there's going to be 2 rows. And then we're going to get rid of the failure type here, okay? Because now instead of there being a failure, we're going to model much more precisely the running out of the coffee in the urn, and then the fact that it needs to go get refilled. And we're going to do that by having a task sequence with 2 rows, okay? When you click on the task sequence, you're going to get this 3 dots over here, and this is what we're going to populate. The task sequence is dispensing the coffee. That's going to be a certain amount of time, right? And that's going to be the former processing time. So that's processing time based on our entity type, which is done over here, right? And we assign that on the initial arrival here. And then we have to refill the urn. And that's going to happen whenever we're below a certain threshold, in this case, if we can't fill up the current coffee. And we're going to have to get that size, that material, from the entity type. Remember, the small, medium, large all have different ounces that they take. Okay, so how do we do that? Well, we go there and we add 2 processing tasks. We labeled one of them self-serve fill. The processing time is from the coffee type table.fill time. Remember, that's going to be from the entity as it shows up there. It comes equipped with a fill time. And then the quantity, well, that's going to be the coffee type table.ounces. And remember, this is one of these fill spots where if you click on it, it will actually give you a menu, or you can just type it out as it were here. Okay, so that's how you model that. Now, we're going to need to say, right, so this is still the same thing I said last time, where this slide is really about the task sequence of filling it and the time it takes, and then this slide is all about, well, now you have to have the material name. And I think the thing I didn't mention in the last slide is you have to say it's self-serve coffee for the material name, okay? And then you reference the ounces in the coffee type table, okay? So now we're going to model refilling the urn. So in that, when we click on the refill self-serve, we have to rename it refill self-serve. And then we have a conditional branch type. The conditional branch type is when the self-serve coffee.quantity in stock, and this quantity in stock is one of these properties of this object. So if you were to start typing in the window, or if you just click on the window, it'll bring up a bunch of things. You have to select the material, self-serve coffee.quantity in stock. And then if that's less than coffee type table.ounces, then we have a processing time. That's that random.triangular 125 that we had before. Now we're putting it here because we're modeling the process specifically. And then we have to change the material. we have to go and change right. So we have to change the resource requirements so that we make sure that the baristas is tapped into. We have to grab a barista because a barista actually has to do the work. And the off shift rule is they suspend processing. So we make sure that we have the resource requirement there as well. Okay. And then the material requirements is that we produce. Okay. So we've depleted it. Now we have to produce, and we produce the self-serve coffee. And remember that the earn capacity is 800. Okay. And that's how you handle that. Now, in the next, if you go to the next lecture, you might be thinking, so the way we modeled it here is that every single entity is, in some sense, their order. And that's going to be a little limiting. So in the next lecture on states, we're going to talk about how we generalize that so that these entities, we sort of have food, like in this case, coffee entities that are assigned to our main customer entity.